In this lecture, I am going to start the design of channel bearing. So first we will see the design procedure, then we'll discuss a simple problem on design of channel bearing, so that you will get a clear understanding about how to design the channel bearing. So we'll start with the design procedure. So the first point in design of channel bearing is channel dimensions. So first of all, if you take the problems, in all the problems they will give three dimensions. One is the load W and the diameter D, then the speed N. Okay, so these three values will be given: load and diameter and the speed. Okay, so we are going to solve the design procedure by using the kgf and centimeter units, that is mk is unit. Okay, so we are not going to use Newton or mm, we are going to use kgf and centimeter. So instead of Newton we have to use kgf, and instead of mm we are going to use the centimeter. Okay, because all the constant values and equations are based on kgf and centimeter only, so keep that in mind. So the first point is channel dimensions. So the diameter of the channel, capital D, it will be given in the problem, and if it is given in meter or mm, you better convert it into centimeter. Okay. Then after calculating, after writing the diameter of the bearing, diameter of the channel, the next part is calculation of length of the channel. Okay. So to calculate the length of the channel, we must find the ratio between L and D, that is length of the channel and diameter of the channel. Okay, so to find the ratio of length and diameter, we can have a look at data book page number 7.31. Okay, so this is the table in data book page number 7.31. In that you can see various applications of channel bearing. Okay, for example, if you take a centrifugal pump, so for example, if our objective is to design a channel bearing for a centrifugal pump, then you can refer this row. So for a centrifugal pump, the L by D ratio is between 1 to 2. Okay, so L by D ratio is equal to 1 to 2. You can fix any values in between 1 to 2. Then after taking the ratio of L by D, then the next step is length of the channel. So L is equal, for example, if your L by D ratio is 2, then further L is equal to 2 times the diameter. So you know the value for diameter, you can calculate the length in centimeter, keep that in mind. Then the second step is pressure developed. Okay, so from the standard we have some standard pressure values. We have to check whether our selected dimensions will be suitable for these applications or not. So for that we have to calculate the pressure value. So this equation is not there in the data book, keep that in mind. So the equation for calculating bearing pressure P is equal to W divided by L into D. So here W is load in kgf, not Newton, because we are going to solve the procedure in kgf and centimeter square. So W is load in kgf. If the load is given in Newton, you can convert it into kgf by dividing 9.81. Then L is length of the channel in centimeter and D is diameter of the channel in centimeter. Okay, so you will get P value in kgf per centimeter square. Okay, so now if you take the chart, then you have the standard allowable bearing pressure values in kgf per centimeter square. So for centrifugal pump, you can see that the pressure should be in between 7 to 14. So if the pressure is less than the 14, that is the maximum value, then it is suitable. So the selected dimensions are suitable. So if the pressure value is high, for example, if your calculated pressure value is 15, then you have to increase the length value. Okay, so you can move from 2D to, you can put a ratio of L by D is equal to 3. Okay, so if the value is greater than the allowable pressure, then you can improve the length of the channel. So most probably your calculated pressure value will be less than the bearing pressure. Okay, so if the calculated P value is less than the allowable bearing pressure, then the design is safe. So you can write a statement like that. So this is the second step. Then the third step is selection of lubrication oil. So in sliding contact bearing, we are going to use lubrications in between the channel and the your bearing. For example, so this is your channel and we have a bearing around that. So this region is covered by lubricant oil in case of sliding contact bearing. So in case of rolling contact bearing, we will have balls and rollers in between the two rays. So in case of journal bearing, we are going to use the lubricant oil. So for that we have to select the lubrication oil. So in some of the problems they will directly give the Z value. So if they directly give the Z value, then you can directly use the value, or otherwise you have to calculate the Z value from the standard data. Okay. So to calculate the lubricant oil, first we have to take the Zn by P ratio. So I'll tell you what is Zn by P. If you take this chart, at the top right side you can see the Zn by P value. So for centrifugal pump, the Zn by P value is 2844.5. Okay, so you can take the Zn by P value from data book. So here Z is the viscosity of the oil, that is absolute viscosity of the oil in centipoise, and N is speed in RPM, and P is the bearing pressure, that is calculated pressure in kgf per centimeter square. Okay, so once after calculating the Zn by P value, for example, for centrifugal pump it is around 2822. Okay, so after finding Zn by P value, you can substitute the value of P and N in the equation, and you can calculate the value of Z, because we know the value of pressure and speed. Speed is given in the problem, pressure we have calculated in the previous stage. So Z is the absolute viscosity of the oil in centipoise. Okay, so now this is the required lubricant oil. But if you take the standard lubricant, then we have standards like SAE 70, SAE 60, SAE 50 oil. So we have to select any one of the standard oil. Okay, so for that, you can refer this graph from page number 7.36, I think. Okay, so the x-axis is temperature in degrees Celsius, and the y-axis is absolute viscosity in centipoise. For example, if the operating temperature, that is TO, is given in the problem, you can take the operating temperature, or otherwise you can take any one of the operating temperature in between 60 to 80 degrees Celsius, because normally the bearings are operated at a temperature of 60 to 80 degrees Celsius. So for example, if I assume TO as 70 degrees Celsius and the calculated viscosity value as 12 centipoise, then you can see that for 70 up to 12 you can go. Okay, so this is 12. So this is your point. So the next standard lubricant is SAE 20. So the selected lubricant oil for this application is SAE 20. And for SAE 20 at 70 degrees Celsius, you can see that, yeah, so around 14 centipoise is the standard Z value. So for the calculated Z, we have to select the standard oil, and for that standard oil, then we have to select the standard Z value. Okay, so just keep these things in mind. While solving the problems, you will get a clear idea about how to select the Z value. So this is the third step, that is selection of lubricant oil. Then the fourth step is calculation of coefficient of lubrication. Okay, mu value. So this equation is there in the data book 7.34. So you can refer the scanned copy of the data book. So that is 33.35 divided by 10 power 10 Zn by P. So here Z is absolute viscosity, that is the last viscosity, the standard viscosity what we have selected, and N is speed in RPM, then P is the bearing pressure in kgf per centimeter square, D is the diameter in centimeter, C is actually the diameter clearance. I'll tell you how to select the value of C, then plus K is the constant. Okay, so first we'll calculate the K value. So to calculate the value of K, you can see this graph in page number 7.34. So page number 7.34, the x-axis is L by D and the y-axis is K value. So for example, if you take a L by D value of, so here I have assumed the L by D value of 2. So for L by D value as 2, then your K value is, it is in between 0 to 0.005. So you can assume a value of 0.0025. Okay, so this is the K value. So this chart is in the data book page number 7.34. You can refer that. The next one is C, that is diametral clearance. So diametral clearance chart is available in page number 7.30. Okay, so if you take 7.30, then you have a different kind of bearings. So in that you can refer the pressure. P is equal to greater than 35 kgf per centimeter square. Here P is less than, less than 35 kgf per centimeter square, and here it is greater than kgf per centimeter square, and this is shaft diameter in mm. For example, if you have a P value of 50, that is greater than 35 kgf per centimeter square, and if you have a 100 mm shaft diameter, then less than 150 and P is greater than 35, you can select this value. So your C value is in between 113 to 163 in micron. So micron means it is 10 power minus 6 meter. So anyway, we have to substitute the value in the equation in centimeter. We have to convert the micron into meter first. Then further you can convert the meter value into centimeter, and you can substitute in the equation. Okay, so that is the C value. So this value. So the remaining values are known. You can substitute everything and you can calculate the value of the coefficient of lubrication. The last step is heat calculation. So amount of heat generated during the operation and amount of heat dissipated by natural convection. So heat generated, Hg is equal to mu W V. So for the last part, we are going to solve the problem in Newton meter per second. So for the first four points, we have used kgf and centimeter, and here we are going to use Newton meter and second. Keep that in mind. For the first 4 points, we have used kgf and centimeter as units. For the fifth point, we are going to use Newton meter and second. So don't confuse the units. Okay. So if you follow my procedure and if you follow my approach, it will be very easy for you. That's why I am insisting the units. So the equation for heat generated is Hg is equal to mu Wv. So this equation is there in the data book page number 7.34. So all these equations are there in the data book. Okay. So I have given you the scanned copy. You can refer that. So here Hg is the heat generated, mu is the coefficient of lubrication, that what we have calculated earlier. W is load, and remember that here we have to substitute in Newton because we are going to get the Hg value in watt. Watt means it is Newton meter per second. Keep that in mind. Okay. Then V is velocity in meter per second. It is pi d n by 60. So if you substitute the d value in meter, you will get V in meter per second. Don't substitute in centimeter. Okay, so for the fifth point, be clear about the units. Substitute D in meter, so only you will get V in meter per second. So if you substitute V in meter per second and W in meter, you will have W in Newton, you will have W as Newton, then V is meter per second. And we know that Newton meter is torque, joule. It is joule, then joule per second. We know that joule per second is watt. Okay, so that is amount of heat generated. The next one is amount of heat dissipated. So this is the equation for calculating amount of heat dissipated. So this equation is there in the data book page number 7.34. So it is del T plus 18 whole square L into D divided by K. So here del T is the temperature difference between operating temperature and atmospheric temperature. Okay. So mostly the operating temperature will not be given in the problem. You can assume a value of 60 to 80. So previously for calculating the viscosity, I have assumed the TO value as 70. Then the atmospheric temperature, we know that it is 28 to 30 degrees Celsius. So that is how we have to calculate the del T. Then here L is the length of the channel. Remember that L we have to substitute in meter, and D also we have to substitute in meter. Then K is the heat dissipation coefficient. I mean heat dissipation constant. It is not coefficient. So K is equal to 0.434. So remember this value. This is not there in the data book. Okay. So if you substitute everything, you will get kg in watt. So the last important thing is, if the heat generated is greater than the heat dissipated, then artificial cooling arrangements must be provided for proper functioning. So Hg is the generated heat and H. So this is actually Hd, not Hg. So Hd is the dissipated heat. So if the heat generated is greater than the heat dissipated, then the remaining heat will be in the bearing, and that heat should be removed to provide a proper functioning to the bearing. So that is why in some of the heavy load bearings artificial coolings are used. So this is an example for artificial cooling. Here a lubricant oil is given inside the bearing and it is taken out. Okay, so this is for rolling contact bearing. This is not for sliding contact bearing. In case of sliding contact bearing also the procedure will be similar. Okay, so if your calculated Hg value is greater than Hd, then you can write a statement like, since the calculated since the heat generated is greater than the heat dissipated, external cooling arrangements must be provided. Okay, so that is the important points. It carries some marks. Okay, so this is the design procedure of channel bearing. So we'll solve a problem on that so that you will get some idea. Design a channel bearing for a steam turbine for the following specifications. So the load on the channel is 20,000 Newton. The diameter of the channel is 100 mm and the speed of the channel is 1500 rpm. So these three datas are given. So we'll start the given data. W is given as 20,000 Newton. So convert it into kgf. It is 20,000 divided by 9.81. So it is 2038.7 kgf. Then D is 100 mm, that is equal to 10 centimeter, and N is equal to 1500 rpm. So we'll start from the first point, that is channel dimensions. So the diameter of the channel D is 10 centimeter. It is given in the problem, and in the problem the application. So to select the value of L by D, you must look into the application. That is the application is a steam turbine. Okay, so for steam turbine you can refer the chart. So we have a centrifugal pump machine to, yeah, so here we have steam turbine. Okay, so for steam turbine the L by D value is in between 1 to 2. So I have assumed a L by D value of 1.5. Okay, so the length of the channel L is equal to 1.5 times of the diameter. It is 1.5 into 10. So that is 15 centimeter. Then the pressure developed. Okay, so the equation for calculating the pressure developed is W divided by L into D. W is load in kgf. Keep that in mind. It is 2038.7. L is the length and D is the diameter in centimeter. So the calculated P value is 13.59 kgf per centimeter square. So now we have to check whether the calculated value is less than the allowable. So for steam turbine you can see the bearing pressure. It should be between 7 to 20 kgf per centimeter square. So since the calculated value is less than the allowable value, the design is safe. So we can move into the third step. So the third step is selection of lubrication oil. Okay, so here we have to select the Zn by P value. You can refer the chart. For steam turbine, the Zn by P value is 1422.3. Okay, so you can write that Zn by P is equal to 1422.3. So in the Zn by P, N is speed in rpm, that is 1500 rpm. It is actually given in the problem. Then P is the pressure developed. it is 13.59. So if you solve the equation, then you will get Z value as 12.88 centipoise. So this is the minimum allowable lubricant. Okay, so we can select the standard lubricant. So here in the problem, the operating temperature is not given. So I have assumed the operating temperature value of 70. So for 70 and 12.88 is the minimum. So you can put a straight line. So for 70 and 12.88, so this is actually the point. Approximately this is the point. So the next standard oil is SAE 20. So the selected oil is SAE 20, and for SAE 20 at 70 degrees Celsius, the lubrication is around 14. So this is the standard Z value. So the standard Z value for SAE 20 at 70 degrees Celsius is Z is equal to 14 centipoise. So the next step is calculation of coefficient of lubrication. So you can refer the equation from 7.34. Mu is equal to 33.25 divided by 10 power 10, 14 into 1500 divided by 13.59. So this is actually Z n by P, and here it is D by C. The diameter is 10 centimeter. So we'll calculate the K first. So in this problem, the L by D value is 1.5. Okay, so if L by D is 1.5, then K value is, it is in between 0 to 0.005. So K value we can take it as K is equal to 0.0025. Okay, so the selection of K is based on the L by D ratio. So this chart is there in the data book page number 7.34. The next one is we have to select the value of C. So for selecting the C, you can refer the chart from 7.32. Okay, so here the pressure value is less than 35 megapascal. Okay, so or otherwise you can refer a electric motor, or you can refer any general purpose machines. Okay, so here since the bearing is used in a turbine, so I have referred this. Okay, so you can refer any one of the application. So I have considered this, and the shaft diameter is 100 mm. So here the shaft diameter is in mm. So for shaft diameter of 100 mm, so the next standard value is 140, and for this electric motor application, the C value is in between 75 to 150. So I have considered a 150 value, C value of 150 micron, that is 150 into 10 power minus 6 meter. So you can take any one of the value, because the C value wouldn't affect the coefficient of lubrication much more. Okay. So to convert the meter into centimeter, I have multiplied 100. So I will get 150 into 10 power minus 4 centimeter. So this is the calculated C value. So we can substitute this in the equation. So C value is 150 into 10 power minus 4, and K value is 0.0025. So if we solve this equation, we will get mu is equal to 5.9 into 10 power minus 3. So remember that always your mu value will be in minus. So 10 power minus 10. Okay, so you will have a coefficient of friction of less than 1. So your value will be in between 0 to 1. Okay, so keep that in mind. Then the last step is calculation of heat. So we'll start from heat generated. So remember that for the fifth step we have to use Newton, meter and second, not kgf and centimeter. So the equation for calculating Hg is equal to mu W V. So mu, you can substitute the value W in Newton, it is not kgf. So Newton is 20,000, and V is the velocity, it is pi dn by 60. So it is pi into 0.1 into 1500. So here I have substituted the diameter value in meter. So that is very important. So the diameter is actually 10 centimeter. I have converted it into meter. That is 0.1 meter. So if I substitute the diameter value in meter, I will get V value in meter per second. So the calculated V value is 7.85. I can substitute it so that I will get a Hg value of 926.3 watt. It is not Newton, it is watt. Okay, so this is the heat generated value. Now the heat dissipated. So Ht is equal to del T plus 18 the whole square LD divided by K. So del T, I have assumed previously, I have assumed the operating temperature of 70 degrees Celsius, and TA, it is atmospheric temperature, it is 28 degrees Celsius. So del T, that is temperature difference, is 21 degrees Celsius. And the L value, so here we have to substitute the L and M in meter. So be clear about it. Units are very important in channel bearing design. So L is length, that is 0.15 meter, and M is diameter, D is diameter 0.1 meter, and the K is the constant, that is 0.434. So remember this constant value. So I will get a Hg value of 52.56 watt. So in this problem, the heat generated value is greater than the heat dissipated. So I am going to write a statement like, since the heat generated is greater than the heat dissipated, artificial cooling arrangements must be provided for proper functioning. Okay. So this is an important statement. So this is the design procedure of channel bearing. So this is the tutorial problem. Design a channel bearing for a generator. So here the application is generator. So while selecting the L by D value, bearing pressure and Zn by P, select accordingly for the following specifications. So the load on the channel is 12,000 Newton. It is given in Newton, convert it into kgf. Then the diameter of the channel is 75 mm, convert it into centimeter. Then the speed of the channel is 1400 rpm. Okay, so these three data are given and the application is generated. You can start from the point number 1, that is channel dimensions, and you can calculate all the dimensions. Then you can select the standard lubricant. Then finally you can calculate the Hg and Hd, and you can compare the heat generated and heat dissipated values.